Scripting for the Web, WS300, Platt College. Part 1, Logic. So here is the dictionary definition of logic. Obviously in this class we're more focused on definition 2, a system or set of principles underlining the arrangement of elements in a computer or an electronic device so as to perform a specified task. In order for things to make logical sense to the computer, there are a few types of operators that we must learn and understand. Throughout this course, I'm going to try to teach you the proper terms for these things, and there are different operators available in JavaScript. So here's a quick overview, and we'll go through each of these now. So your math operators, pretty much what you'd expect: addition, subtraction, multiplication, division. We can use the power of or exponents. And then the last one being the assignment operator. Technically, this isn't really a math operator because it doesn't do math. But because you're used to seeing an equal sign as part of an equation in algebra, I included it here. So technically this isn't a math operator, it is the assignment operator. An equal sign in math basically means that the items on each side of the equal sign are equivalent. So we have A equals 10. 10 is A and A is 10. They are the same. This is why we use the equal sign as the assignment operator. Let's look at this code. Here the value of A is equal to 10 and the value of B is equal to 20. So when we look at the question here, what is the value of A? Well, we know that the value of A is 10. What is the value of B? It's 20. When we get to the end of our code, A equals B, what is the value of A at this point? And what is the value of B? Well, they're both 20 because we've reassigned the value of A to the value of B, which is 20. So now they are both 20. Here we have the plus sign. The plus sign does two different things. It can add numbers together and it can concatenate strings. So it's a kind of weird thing that JavaScript does, but I kind of remind myself that the plus sign always adds. It adds strings together and it adds numbers together. But the plus sign favors concatenation over addition. The other math operators are more standard. So for example, the minus, the dash, is always recognized or always seen by JavaScript as a minus. I'll get to that in a minute. So here we have the value of A, 10, a number, the value of B, 20, a string. If we add A plus B together, C actually is the value of 10, 20, not as a number, but as a set of characters, as a string. And that's important to understand when you're trying to add values together. If they're numerical format, but not numbers, they're going to be added as characters. So there's a difference between a character number 1, which is essentially a string, and a number value 1, which is a number. So the minus sign. Here we have A equals 10 and B equals 20. And that 20 is a string. So what is the value of C? If we know that the minus sign always subtracts, we take the value of A and subtract B from it, we're going to get C as a value of negative 10. Because JavaScript recognizes that both items are numerical, even though one is a string data type, it is a numerical format, and therefore it will subtract. All other math operators work like you would expect. JavaScript does not recognize the minus sign as anything but a minus. And this is why background dash color has to be stated as background capital C color in pure JavaScript, or encased in a string such as background dash color when we start using jQuery, or as we saw in the case of CSS text. So the modulus operator I actually previewed for you guys on day 1. And What the modulus operator does is it gets the remainder of the division between the two numbers. So 14, or 5 goes into 14 twice with a remainder of 4. Therefore, when we assign the value of 14 modulus 5 to the variable called the remainder, its value is 4. It divides it and finds out what's left. The modulus operator can help us find the factor of a number by telling what numbers divide into it with a 0 remainder. So if I did 15 modulus 5, I'd get the value of 0 because 5 goes into 15 evenly. And that might be useful for you if you're doing something that requires that information. So comparison operators, and this table is taken directly from the W3 schools in order to create conditional statements that return Boolean values of true or false. So whenever we use a comparison operator, we check to see what the value of the two sides are, and then is this true or is this false? If it's true, then we want to do the following code block. If it is not, then we want to do something else or ignore the code block entirely. So a conditional statement will only execute if that condition is true. It'll render the following code block afterwards. That's why I mentioned parentheses are like necessary pieces of information. And then the curly braces, that code block says what to do following this piece of information. So here we can see that if x is equal to 5, the first line here is x equal to 8? That's a question we're asking. So when we look at the comparing line here, where's my little laser pointer? There it is. So when we look at the comparing line here, x has the value of 5. Is it equal to 8? That's not true. So it would return false and not execute the code block that follows that question. So think of comparison statements as asking a question. And what you want to know is this true or not? And if it's true, do X, Y, Z. If it is not true, then do something else. The triple equals basically tests if both items are a string. If they have the same value and are of the same type, then it would be true. So here we can see x, the number 5, is not equal to the character 5. So that returns false, versus the number 5, is that equal in both value and type? Then yes, that's true. Number 5 is equal to number 5 in both value and type. We use the exclamation point to check if something is not equal. If I just use x is not equal to 8, x has the value of 5. Is it equal to 8? 5 is not equal to 8. That is true. Is number 5 not equal to string 5? Well, that's true, because we've got this kind of triple or three comparison here, not equal to value or type. And sometimes you might want that specificity. You don't always need it, but sometimes you might want it. Greater than is pretty straightforward. It's like, is x greater than 8? So x, which has the current value of 5, is that greater than 8? No, that's false. Is x 5 less than 8? That's true. Is x 5, is 5 basically greater than or equal to 8? That's false. And is x, being 5, less than or equal to the value of 8? Well, that's true. Then we have these compound logical operator conditional statement. This is a way that we can check more than one condition at the same time. So here's the table from the W3 schools in order to create conditional statements that return values, Boolean values of true or false. When it comes to logical operators, we can state more than one conditional statement within the parentheses, or basically our if statement. If we use ampersand, the double ampersand, that basically says both or however many conditions that we put into the set of parentheses, all of that needs to be true. So in this case, we would say, is x less than 10 and is y greater than 1? X, which current value is 6, is that less than 10? Yes. Then we're going to check the second condition. Is y greater than 1? Y's current value is 3. So yes, it's true. Or the pipes, that's what that's called, those two pipes. This checks to see if one of these is true. X's current value is 6. Is 6 equal to 5? No. Let's check y. Is y equal to 5? Y's value is 3. So 3 is not equal to 5. That's why this renders out as false. But if I was checking to see if x was equal to 6, it would be true. The exclamation point, also known as the bang, is basically the inverse of what is true. So the not operator, as it's also referred to. Basically, just like before, it means cancel this out. What I'm really looking for is the false value. Is x not equal to y? A better way to write this, of course, just would be the x not equal, but sometimes you might want to find out if a larger set of things, if that condition comes back as false, you want to check, are all, any of these false? Does it return a true value? Then I'm looking for the false value. Compound assignment operators are used to assign a value to itself. Given that x is 10 and y is 5, the table below explains the compound assignment operators. Our assignment operator just says, assign the value of y to x. X equals y, and then result in x is now 5. Because x was 10, and then we reassigned its value to the same value as y, x is now 5. When we plus equals, we add the value of y to x. We could write that as x equals x plus y, and now the value of x would be 15 after that bit of math was done. So minus equals, same thing, only subtracts. So x minus equals y can be written as x equals x minus y, which then turns around and makes the value of x 5, because 10 minus 5 is 5. Times equal, so it multiplies to itself. So here we're going to take x and multiply it by y. As you can see, x equals x times y. The result of 10 times 5 is 50. All right. And then divide equals x divided equals y. X equals x divided by y. Well, that now is the value of 2. X is now the value of 2. And then the modulus operator. X modulus equals, so basically we're going to take the remainder and reassign it to the value of x, whatever that remainder is. So if we take 10 modulus y, 5 evenly divides into 10, so we have no remainder. That means x is now equal 0.